Namaste and welcome to this video. In this video, I am going to give you some informations about the electrical discharge through gases. यस भिडियोमा म तपाईहरुलाई इलेक्ट्रिकल डिस्चार्ज थ्रु ग्यासेसको इन्ट्रोडक्सन त्यस्तै इलेक्ट्रिकल डिस्चार्ज थ्रु ग्यासेस एट भेरियस प्रेसर हुँदाखेरि कस्ता कस्ता इभेन्ट्सहरु हामी अब्जर्भ गर्न सक्छौं त्यसको बारेमा पनि म बताउने छु। त्यसै गरेर यसको अन्तिममा म तपाईहरुलाई हाउ क्याथोड रेज आर फर्मड एन्ड व्हाट आर द properties of cathode rays त्यसको बारेमा पनि जानकारी गराउन चाहन्छु। अब लागौं हामी इलेक्ट्रिकल डिस्चार्ज थ्रु ग्यासेसको बारेमा बुझ्न। सो the flow of electric current through a gas is called electrical discharge through gases. We can find electrical discharge through gases during lightning. चट्याङ पर्दाखेरि पनि हामी एयरबाट करेन्ट फ्लो भएको पाउँछौं। त्यसै गरी when two wires are short circuited then a spark is produced, that is also an example of electrical discharge through gases. At normal temperature and pressure, gases are insulators because they do not have free charge particles needed for conduction. All the electrons in an atom are bound to their respective nuclei and the molecule as a whole is neutral. At atmospheric pressure, normal pressure and temperature, यदि कुनै free electrons charge particles छ भने पनि they cannot conduct electricity continuously because the mean free path between the molecules is very less. So ion अथवा charge particles चाहिँ less kinetic energy ले accelerate गर्छ. But when the pressure is very low and the potential difference applied across in a given gas is very high, then that gas can conduct electricity because at that condition we can find large number of ions as well as mean free path between the molecules is also very high. कुनै ions form भएको छ भने त्यो ions चाहिँ long distance सम्म travel गर्दाखेरि they travel with the large amount of kinetic energy which can knock out electron from the neutral molecule and the process continuously occur such that charge particles, positive ions and negative ions flow through the gas that set up a current in a gas. So this flow of electric current through a gas is called electrical discharge through gases. Now we are going to discuss on the device called discharge tube. Discharge tube is the device in which we study the flow of electrical current through gas. Here you can find a picture of a discharge tube. This is the picture of a discharge tube and this is the schematic diagram of a discharge tube. This discharge tube is made up of glass which is of cylindrical in structure. Its length is about 20 to 30 cm and diameter is about 4 cm. Its both ends are closed and we can find two electrodes at its end, ends A and B. They are connected to a secondary coil of a induction coil. And the two electrodes are made up of platinum or aluminum. There is a side tube connected to the discharge tube and this side tube is connected to the manometer or pressure gauge and a vacuum pump. Here vacuum pump is used to vary the pressure inside the tube and pressure gauge is used to measure the pressure inside the tube. So during study of electrical discharge we need to vary the pressure, so vacuum pump and manometer or pressure gauge are connected. Two electrodes are connected to the secondary coil which can provide very high potential. The potential difference across electrodes is about 50 kilovolt. So now let's study on gases discharge at various pressure. We came to know that no discharge passes through the discharge tube at atmospheric pressure due to lack of ions. But what happens when the pressure is reduced to 10 mm of Hg? So when the pressure is reduced to 10 mm mm of Hg mercury, the electrical discharge starts to pass between the electrodes with a crackling sound. At this pressure, we can find violet irregular flash across the tube, and the when the tube is further evaluated, it takes the shape of a single rope-like structure. This single rope-like structure is called streamer. As I already mentioned, a crackling sound is also produced at this pressure. On further decreasing the pressure of about 5 mm of Hg, we can find that the streamer broadens and the discharge becomes bright and steady. At this pressure, we can find a luminous column called positive column between the tube, which starts from anode and it spreads the whole tube. This discharge is also called Gessler's discharge. During this discharge, we can find a color light of different color. The nature of color depends upon the gas present inside the discharge tube. So we can find red color for air, blue color for hydrogen, similarly white color for carbon dioxide. Now what happens when the pressure is further reduced to 2 mm of mercury? Now let's try to understand. At pressure of 2 mm of Hg, we can find that the positive column, which starts from the anode, occupies the greater part of the tube. The positive column is separated from the negative glow and the cathode by a dark region called Faraday's dark space. So we can find a certain glow at the cathode that is called negative glow, and initially positive column occupies the whole tube, but gradually when the pressure is reduced, positive column gets detached from the cathode and shift towards the anode. So a dark space is formed between negative glow and the positive column that is called Faraday's dark space. So on further reducing the pressure, pressure is reduced up to 0.4 mm of Hg. Now what happens? Let's try to observe. So when the pressure is reduced to 0.4 mm of Hg, positive column shortens and break into alternate bright and dark discs called striations. The Faraday's dark space shift towards the anode. The number of striations increases till the pressure is down to 0.24 mm of Hg. As the pressure is decreased further, length of the positive column decreases and the length of the Faraday's space increases. At the same time, negative glow leaves cathode and shift toward the anode. At the same time, we can find another glow can be observed in the cathode due to striking of positive ions deposited closer to the cathode. And we can find a certain dark space between cathode glow and negative glow. Between cathode glow and negative glow, this dark space is called Crookes dark space. Let's try to study the event below the 0.4 mm of Hg. What happens when the pressure is reduced to about 0.01 mm of Hg? At this stage, all the striations, the negative glow and the Faraday's dark space disappear. The entire tube is filled with Crookes dark space. At this pressure, walls of tube glow with certain color. This effect is called fluorescence effect. The color of the glow depends upon the nature of the glass used. So why the fluorescence effect is produced? It is because of certain rays emitted from cathode strike the walls. So these something invisible rays coming from the cathode are called cathode rays, And the experiment is performed even at the pressure of 10 to the power minus 4 mm of Hg. At this pressure and below this pressure, no discharge passes through the tube, as there are very few particles, gas particles, available for conduction. Now I am going to discuss how cathode rays are produced. So when a discharge tube is exhausted to pressure of 0.01 millimeter of mercury, the whole tube is filled with Crookes dark space and the wall of tube starts to glow. It indicates that something which comes out from cathode strikes the wall and causes wall to glow. So this something coming from cathode as a stream of invisible rays are called cathode rays. These fast moving invisible particles are later called electrons. So up to this I have discussed how cathode rays are produced. Now let's move to the properties of cathode rays. There are different properties of cathode rays. The first one is cathode rays are emitted from the cathode normal to the surface, and their direction is independent of the position of the anode because of the presence of the gas molecules in the tube. They travel in a straight path and can cast shadow of an obstacle placed in their path. Next one is they produce fluorescence effect when they fall on certain substance. The color of fluorescence depends upon the nature of the substance they fall upon. Next property is they can induce chemical change and thus affect photographic plates. Another property is when they strike a metal target of high atomic number such as tungsten, molybdenum, they can produce highly penetrating radiation called X-rays. Similarly, next property is they can produce heat when stopped by matter because they exert mechanical pressure and they possess large momentum and kinetic energy. When cathode rays with large Ke strike the matter, their kinetic energy is converted into heat energy. From number of experiments, it came to know that they carry negative charge, and due to presence of charge, they are deflected by both electric and magnetic fields. Their speed is of about 10 to the power 7 meter per second. They can ionize the gas through which they pass. They can penetrate through thin sheet of paper too. So these are the properties of cathode rays. So in this video I have discussed the basic information about the electrical discharge and different events observed at different gas pressure and how cathode rays are produced, and I have discussed the properties of cathode rays. Thank you for watching my video.